Hey everyone, Mr. Newman here, and we're going to do an example quiz or practice quiz for factoring polynomials. First thing you need to know is all of these we're going to be factoring, but there's three different ways so far we've learned to factor. One way is finding the greatest common factor. Another way is factoring trinomials into binomials. And the third way is finding the difference of squares. So the first thing you have to do is identify which problem you're doing. What I would recommend is always try the GCF first, because you might find the greatest common factor inside, be able to pull it out first, and then use one of the other techniques to factor. When factoring down to binomials, you'll always start with a trinomial, something like x squared plus 5x plus 6. And for difference of squares, that's going to look like this. One expression squared minus another expression squared. And it's really helpful to identify and know your perfect squares to that one. So let's get started on this. The first one I'm going to do is I'm going to try to find a GCF, because it's not a trinomial and there's not subtraction there. So it's probably going to be greatest common factor. The greatest common factor is 3x. So when I ask you to factor this, you need to make sure you write 3x and then in parentheses whatever is left over when you divide out or remove 3x. Let's see, 6x squared divided by 3x is 2x, and 9xy divided by 3x is 3y. So that is the expression that's left over. How do you check your work? We distribute it and multiply it back out. So when you distribute 3x to both of those expressions, you'll see that you get 6x squared plus 9xy. This is a really good technique to use if you're not sure of the answer, but I would recommend that everyone be checking their work on this quiz, because it should be a pretty fast quiz. That right there, 3x times parentheses 2x plus 3y, is the answer. For the next one, there's no greatest common factor because there's not an x on all of the terms, and there's no other coefficients in the first one, so we're going to move on, and it's probably a trinomial that we can factor. Notice the three terms. Remember how we do this? We look for the factors of 6, and we list them out and try to see which ones add up to 5. The factors of 6 that I know are 1 and 6, and then 2 and 3. Notice that 1 and 6 add to 7, but 2 and 3 add to 5, and 5 is what we wanted it to add to because that's the B term, the middle term. So those are the factors we're going to use. We're not done yet, though, because remember, we have to write that inside of x plus something times x plus something. So our final answer is x plus 2 times x plus 3. To check this, I'm going to multiply that out using a box. So I multiply it out, and I should get x squared plus 5x plus 6, and I do, so I know that is the correct answer. For the next one, notice the subtraction. There's no GCF, and it's not a trinomial, but with a subtraction in the middle, that's a difference of squares. And we have x squared, which is a perfect square, and 9, also a perfect square. So we're going to write our parentheses and put plus and minus. Now, what goes in front and behind the plus and minus? Well, the square root of those two things. The square root of x squared is x, so I'm going to put an x there and an x there. The square root of 9 is 3, so I'm going to put a 3 there and a 3 there. So x plus 3 times x minus 3. Let's check and make sure that's the right answer. So when we multiply it out, notice that negative 3x and positive 3x add up to 0, which is what we wanted because there's no middle term there. And we get x squared minus 9, so this is our answer. A little further down, the next one we're going to do is, again, a trinomial. So I'm going to factor 50 and write down the factors of 50. But before I get started, notice I looked at B and saw, oh, there's a minus 15 there. That means that we need to have the factors be both negative because we need it to add up to a negative number. So negative 1 and negative 50 both multiply to get 50, but they do not add to negative 15. Negative 2 and negative 25 are also factors, but they don't add to negative 15. Negative 5 and negative 10 do add to negative 15, so those are my factors I'm going to use. So x minus 5 times x minus 10. Here's the check. We multiply that back out, use the Punnett square, and you'll notice what happens is we get negative 5x plus negative 10x, and that gets our negative 15 in the middle, and we got the correct trinomial. For the next one, I'm going to check GCF first. Notice I know it's not a difference of squares, because even though there's a lot of squares in there, that's a plus, and those 12 and 24 are not perfect squares, so they are not going to be a difference of squares problem. So in finding the GCF, I first want to look at the coefficients. What goes into 24 and 12? 12 does. So 12 is part of the GCF, but I also need to look at the variables. X, there's an x in both of them. There's a y squared in both of them, and there's a z in both of them. The reason I can't put x cubed is because the second one only has x to the first power. The reason I can't put z cubed is because the first one only has z to the first power. Now, if that's the GCF, how do we figure out what's in parentheses and left behind? Well, I'm going to rewrite this down here and write out what x cubed and y squared times z all means. So when I take out a 12, I get a 2 left over from the 24. When I take out an x, I'm going to cross one of those out. When I take out the y squared, I'm going to cross two of those out, and you see what's left over. A 2, and a z also gets taken out. So we're left with a 2 and then two x's, which is x squared. I'm going to do the same thing for the next term. I write it out, divide out the 12, I'm left with just a 1. Divide out the x, divide out two y's, and divide out a z. The only things that are left are two z's, that's z squared, and that is my expression. To check your work, you would distribute that back out. For this last one, notice the subtraction, and everything is a perfect square. So we know it's something plus something, and that same thing minus that same thing. But what are those somethings and same things? Well, right here, I take the square root of the first. The square root of 4x squared is 2x. So I'm going to put that in the front. And then 25y squared, the square root of that is 5y. So I'm going to put both of those in the back. And that is my answer. Thank you guys very much for watching.